Hello, today we're going to look at solving quadratic equations by factorising. So I've got 4 examples to take you through, so let's go through them one by one. So first one, if we're asked to solve this, x squared subtract 4x equals 0. Well, in the end we're looking for values of x, and you could do it by a little bit of trial and error. So you could say 0. 0 works, 0 squared minus 4 times 0, yeah, that would work. So you could do it by trial and error, but we're looking for a more systematic way of doing it. So generally, when we see quadratics, remember quadratic at the highest power is 2, when we tend to factorise. So we'll go through our system of factorising. So common factor first of all, difference of 2 squares, pattern 1x squared, table for your 3x squared, 2x squared, etc. So first thing, let's look for the common factor as a common factor. Yeah, x goes into both. So let's take x out. So x multiplied by what gives us x squared? That's x. X multiplied by what gives us negative 4x. That's negative 4. And close off the bracket. Now at this stage we've got two things multiplying together, or two terms multiplied together to equal 0. So if I just go over here, and if we say had a and b multiplied together to give us 0, or equal 0, a could equal 0, because 0 multiplied by b gives 0, or b could b could equal 0, because a multiplied by 0 gives us 0 as well. So either a or b could equal 0 if they're multiplied together. So in this case, we've got x multiplying the x minus 4. So either of those could equal 0. So x equals 0, or x subtract 4 equals 0. So if we rearrange this one, add 4 to both sides, we get x equals 4. So our final solution there, x equals 0, x equals 4. And what we should always do, we should double check that it actually works in the original equation. So let's put the 0 back. 0 squared, because it's 0, minus 4 multiplied by 0, that's 0. So 0 subtract 0 is 0, so 0 works. And 4, let's try 4. 4 squared, 16, subtract 4 multiplied by 4. 4 multiplied by 4, 16, so 16 subtract 16 equals 0. So whenever you can, check back. Right, second equation. Again, a quadratic equation, so let's look at factorising. Is there a common factor? No. Is it a difference of 2 squares? Yes, it is. It's x multiplied by x gives us x squared, and 9 multiplied by 9, or 9 squared, gives us 81. And as soon as we've got that, difference of 2 squares, what? X there, 9 there, 9 there. Subtract and an add in between them, equaling 0. As above, we've got two terms multiplied together, therefore either of those could equal 0. So x subtract 9 could equal 0, or x add 9 equals 0. So in this case, add 9 to both sides. We get x equals 9. In this case, subtract 9 from both sides. So we get x equals negative 9. And those are our two solutions. I'll leave you to double check whether they're right or not. You should always check back in the original equation. Right, on to our last two examples. So, is it a common factor? No. Difference of 2 squares? No. Is it a 1x squared? Yes. So we're going to apply our pattern. So two numbers multiply to give us negative 6, and also add, if I put the number in there, to give us plus 1. So two numbers that multiply to give us negative 6. Let's have negative 3 and 2. What do they add to give? They add to give us negative 1. So that's not going to work. Other two numbers, we're pretty close though, because it's positive 1. So let's try positive 3 and negative 2. They multiply together to give us negative 6, add together to give us plus 1. So those are the correct numbers. So setting up our brackets, it's x squared, or 1x squared at the front, therefore it's x and x. We've got our numbers, plus 3, and subtract 2. Same as before, 2 terms multiplied to give 0, therefore each one of those equals 0. So in this case, subtract 3 from both sides, so we get x equals negative 3, and in this case, add 2 to both sides, so we get x equals 2. So there's your 2 solutions. And again, you can double check back in the original equation to see if they work. Final one, final equation. Is there a common factor? No. Difference of 2 squares? No. 1x squared? No. 3x squared, 2x squared? Yes. So we're going to use our table method for factorising. So 2 terms that multiply together to give us the 3x squared. So let's have 3x and x, and also 2 terms that multiply to give us negative 2. So let's have, let's see, positive 2 and negative 1. So 3 multiplied by negative 1, or sorry, 3x multiplied by negative 1, that's negative 3x. And x multiplied by 2, that's plus 2x. Add those together, we get negative 1x. So that's not going to work because we want the 5x. Now let's try those the other way around, as in the 2 and the 1. So let's put the 2, or the 2 and the negative 1. So let's put the 2 there and the negative 1 there. So 3x multiplied by 2, that's 6x. Add x multiplied by negative 1, negative x. So 6x, add a negative, subtract 6x, subtract x, 5x, excellent. That's going to work. So our brackets are, there's the top one, 3x subtract 1, and the bottom one, x add 2. Remember, 2 terms multiply together to equal 0, either of them could equal 0. So we've got 3x subtract 1 equals 0, and we've got x plus 2 equals 0. Over here, let's add 1 to both sides. So we get 3x equals 1, and then we want x on its own, let's divide by 3. So we get x equals third. And over on this side, subtract 2 from both sides, we get x equals negative 2. So there's your 2 solutions. Again, check back in the original equation to check they do actually work. So please remember, when you're factorising quadratic equations, remember quadratic highest power 2, think about factorising. Goodbye, and thanks for watching.